Manufacturing of tomorrow look like? Industrial parts are becoming smaller. Products get to market with less waste, faster, and on time. Even the most manual processes are turning towards automation. Innovations in machine vision, deep learning, and robotics are revolutionizing production lines and supply chains. Our machines now produce vast amounts of big data, accessible via the cloud. As machines and the information they produce become linked, new cyber-physical systems will spark a modern-day industrial revolution. This is Industry 4.0. In Industry 4.0, smart machines learn from their environments and take corrective actions to optimize production. These machines work independently of a central controller, collaborating and communicating with other devices. Industry 4.0 factories produce new organizational intelligence, which spreads across facilities and is accessible anywhere. The result? Nothing short of total transformation of production lines and business performance.
A vision of tomorrow's manufacturing. Products finding their way independently through the production process. In intelligent factories, machines and products communicate with each other, cooperatively driving production. Raw materials and machines are interconnected within an Internet of Things. The objective, highly flexible, individualized and resource-friendly mass production. That is the vision for the fourth industrial revolution. A bottling plant for liquids set up together with Siemens is used to demonstrate the most important components of the intelligent factory of the future. Each bottle contains an RFID chip storing a precise description of how it has to be processed. Which liquid, which lid, and which label. At each station, the bottle communicates directly with the machine, telling it how it has to be processed. At the end, a computer checks whether the bottle has actually been produced as desired. Factories with networked machines and products are already in existence today. In the future, however, these hitherto self-contained systems will be connected together in a comprehensive network. All devices, machines and materials will be duly equipped with sensors and communications technology and connect to each other. These systems are known as cyber-physical systems. The highlight is that they communicate with each other and also control each other cooperatively.
Molded parts can be instantly and completely inspected. Is there any overmolding? Are all fan blades generated? Is the insert part properly placed? Thanks to patented, contour-based FEX technology with 360 degrees FEX lock part location, VeriSense will detect the different fan blade positions. Mechanical part guidance is therefore completely unnecessary. Easy color inspection, like in vehicle electronics, often turns out to be a challenge. Is every color in the right place? Are all blanks in the defined positions? Is the fuse puller present? What the human eye perceives as brightness, hue and saturation is mapped by the VeriSense Color FEX Assistant in an interactive 3D color model for easy and intuitive color inspection.
A look back at history. At the end of the 18th century, the first steam engines and the intelligent use of hydropower revolutionized production. The late 19th century saw the rise of electrical engineering and mass production. The first moving belt conveyor was used as long ago as 1870 in the slaughterhouses of Cincinnati, Ohio. In the mid-1970s, electronics and IT began to expand rapidly into industry. Siemens developed the first SIMATIC. Production became increasingly based on computer-assisted controls. The fourth industrial revolution is still a vision. Experts believe that it will only become a reality within the next 20 years.